Now here is a question on each parameter. The question says find the hybrid parameters for the two-port network in the diagram below. As we can see, the diagram is just a T network. By now, I believe all of us should know the difference between T network and pi network configuration of diagrams. So in solving for hybrid parameter, that is, you solve for H11, H12, H21, and H22. In solving for this, we'll take two parameters at a time and solve just like we have been doing for other parameters. Another two will solve at another time. Now for us to solve H11 and H21, remember at H11 and H21, for us to calculate it in our formula, our V2 must be equals to 0. From our V1 equals to H11 I1 plus H12 V2. For us to calculate our H11 there, V2 must be equals to 0. That is, our V2 must be open circuit. Also, in calculating for H21 from the formula, I2 equals to H21 I1 plus H22 V2. Our V2 also must be equals to 0 to calculate for H21 there. Our V2 output voltage must be open circuit. Remember we are still solving for H11 and H21. Now in solving for H11 and H21, that is our hybrid parameter, you need your current source I1. You place it at the input side of the circuit, any circuit you are given, and you place a short circuit V2 equals to 0. You place a short circuit at the output side of the circuit. Now doing this, you see that reflected in the diagram shown in this slide. Now going by Ohm's law, which is V equals to IR, your V1 equals to I1 multiplied by your equivalent resistor. Now note certain things, that the only current source you have is the I1, and the I1 is the one producing, a part of I1 is I2. Also, V1 is the only voltage that is available. The input voltage is the only available voltage source in the circuit. The V2 is already 0. So your V1 equals to I1 multiplied by your equivalent resistor. Now, your equivalent resistor, to calculate it, you see that your 2 ohm is in series with 6 and 3 ohms in parallel. 6 and 3 ohms are in parallel, but they are in series with the 2 ohm resistor. When you calculate that, 3 and 6 in parallel, 3 multiplied by 6 over 3 plus 6, that will give you 2 ohms. Add it to the 2 ohm in series, and that will give you 4. So your V1 equals to I1 multiplied by your 4 ohms, and that will give you 4 I1. Now, your H11, your short circuit input impedance, equals to V1 over I1, short circuit input impedance. H11 equals to V1 over I1. Your V1 is already 4 I1, and your I1 is unknown, so 4 I1 over I1. I1 cancel out, and that will give you 4 ohm. Also, going by current divider principle, to calculate for our I2, note I2 is a small portion of I1 flowing in 3 ohm resistor. Another part of the current I1 is flowing in 6 ohm resistor, and that's why we are using current divider principle, because the I1 splits into 2. A part of it will flow in 6 ohm resistor, another part will flow in 3 ohm resistor. But the part of current I1 flowing in the 3 ohm resistor is flowing in opposite direction to the current I1 producing it. So that's why we have minus I2 equals to 6 over 6 plus 3. That's obtained by current divider principle multiplied by your I1. So that will give you 2 over 3 I1. Now to calculate your short circuit forward current gain, that is H21. going by the formula, H21 equals to high 2 over high 1, that is output current over input current. And we already calculated our high 2 to be minus 2 over 3 I1. Divide it by high 1 and you get your minus 2 over 3. Now to obtain our H12 and H22 from the same diagram, we will place a voltage source V2 at the output side of the circuit, and then we will have our high 1, that is our current I1 source, to be equals to 0. So when our current source equals to 0, remember the I1 is the current flowing through the 2 ohm resistor, and if 0 is flowing through, that means we have the 2 ohm resistor is not off. So V1, to calculate our V1 using voltage divider principle, V1 is the voltage across the 6 ohm resistor. V1 is the voltage across the 6 ohm resistor. So going by voltage divider principle, our V1 will be 6 over 6 plus 3 ohm. Remember 2 ohm is no more there. 6 plus 3 ohm multiplied by the total voltage in this circuit, and the total voltage, which is our voltage source, is the V2. So 6 over 9 multiplied by our V2, and that will give us 2 over 3 V2. Now, having calculated for our V1 in slide 8, we can now calculate for our open circuit reverse voltage gain, H12. Now, why is it called reverse voltage gain? Because normally our voltage gain should be output voltage over input voltage. That's when we call it forward voltage gain or normal voltage gain. But it's reverse voltage gain because instead of output over input, we have input over output. So our open circuit reverse voltage gain H12 is input voltage over output voltage V1 over V2. V1 is already 2 over 3 V2 from our calculation, and you can just place your V2 there so that it can cancel out. So you have your H12 to be 2 over 3, no unit, remember. Now, from our previous calculation, we already got our H21 to be minus 2 over 3. So I suspect, and I can easily conclude based on our condition, that for a reciprocal network, H12 must be minus H21. H12 equals to minus H21. So I can easily conclude that this is a reciprocal network. The hybrid parameter is a reciprocal. There is a reciprocal network for this hybrid parameter, since our H12 is equals to minus H21. Also, going further to calculate for our H22, we can say that from our formula we can say that our H22, that is our short circuit admittance, short circuit output admittance, is I2 over V2. Short circuit output, open circuit output admittance. Open circuit in the sense that our current is equals to 0. Open circuit because our current is equals to 0. Current I1, input current I1 equals to 0. So from that formula, I can easily calculate for my V2. Remember from our diagram in slide 8, we have a voltage source V2 that is producing I2, that is producing voltage drop also across the 6 ohm resistor. We can easily say our V2 is equals to, from Ohm's law, I2 multiplied by the equivalent resistor. The equivalent resistor there is the 3 and 6 ohm in series, because our I2 is already 0. So 3 and 6 in series will give us 9. So V2 is equal to I2 multiplied by your equivalent resistor, 9 ohms, and that will give you 9I2. So place that in your formula. Your H22, which is our open circuit output admittance, will be equals to I2 over V2. Our I2 is there, and then our V2 is 9I2. When I2 cancel out, we have 1 over 9 Siemens. Our open circuit output admittance is equals to 1 over 9. I'm going to inverse hybrid parameter. Inverse hybrid parameter is also called G parameter. As admittance parameter is to impedance parameter, so is G parameter or inverse hybrid parameter to hybrid parameter. It simply means that as closely related as impedance and admittance parameter is, so is hybrid parameter and inverse hybrid parameters closely related. They are very, very similar. So they have certain conditions imposed to each of them together. Now, the formula for the inverse hybrid parameter or the G parameter is I1 equals to G11 V1 plus G12 I2. Note, I1 equals to G11 V1 plus G12 I2, and V2 equals to G21 V1 plus G22 I2. Again, V2 equals to G21 V1 plus G22 I2. Now, comparing the inverse hybrid parameter to the hybrid parameter, you will see that for hybrid parameter, we have our V1 and I2 to be the dependent variable, but here we have our I1 and V2 to be the dependent variable, whereas the I1 and V2 are the independent variable in hybrid parameter, and our V1 and I2 are now the independent variable in the inverse hybrid parameter. So we have the matrix form written here. So also note there's no specific unit for the same reason why we don't have specific unit, because they are mixture. Also, they are mixed ratio, combination of different ratio. That for the same reason we don't have the specific or specified units for hybrid parameter is the same why we don't have it for inverse hybrid parameter. Now, from the formula of formulas of inverse hybrid parameter stated in slide 10, we can get our G11, G12, G21, and G22 as follows. Our G11, also called open circuit input admittance. Open circuit because our current I2 is equal to 0. That's why it's called open circuit input admittance. G11 equals to I1 over V1, input current over input voltage, provided that your I2, the output current, equals to 0. And your G12, that is your short circuit reverse current gain. G12 equals to input current over output current, provided that your input voltage V1 equals to 0. Your G21 equals to V2 over V1, provided that your I2 equals to 0. G21 equals to output voltage over input voltage, provided that your output current equals to 0, and that is referred to as open circuit forward voltage gain. And our short circuit output impedance, G22 is equals to V2 over I2, provided that your V1 equals to 0. So the diagram for the model of inverse hybrid network is shown in slide 12.